Hello everyone. In this video, we will cover a mortality law where the force of mortality is a constant. For this constant force of mortality, we take mu x equals mu for all x. The survival function of a newborn S0 is e to the power minus mu x. And Tpx equals e to the power minus mu t, and therefore Tqx is 1 minus e to the power minus mu t. The density function Tpx times mu, we get mu times e to the power minus mu t. And this is a density function for the exponential distribution. So Tx follows an exponential distribution with mean 1 over mu. And therefore the mean, the complete expectation of life, is 1 over mu. The variance of Tx, which is the variance of an exponential distribution, equals the square of the mean. The variance of Tx is 1 over mu squared. And for the expected value of Kx, the curtailed expectation of life, which equals the summation of Kpx, where K equals 1 to infinity. This forms a geometric series, and we can simplify this as e to the power minus mu over 1 minus e to the power minus mu. These are the formulas you need for the mortality law where the force of mortality is a constant. Let's take a look at two examples. The first one, given that the force of mortality is a constant where mu is less than 1, if the probability that an individual at age 80 dies between ages 83 and 86 is 0.01, calculate the force of mortality mu. All right, we are given that 3 bar 3 Q80 is 0.01, and 3 bar 3 Q80 can be expressed as 3P80 minus 6P80. Tpx, by definition, we get e to the power negative the integral of the force of mortality. And this equals e to the power minus mu t. And for the force of mortality, the Tpx is independent of the age x. All right, we need to get the value for 3P80 and 6P80. We substitute t equals 3 and t equals 6 into the expression of Tp80. Then we get a quadratic equation. Solve for the value of e to the power minus 3 mu. And then we can further determine the value for mu. Mu equals 1.5317 or 0.0034. And we are given that the force of mortality is less than 1. So the answer for this is 0.0034. Let's take a look at another example. Given that the force of mortality mu x is 0.052 for all x, calculate the 25 years temporary expectation of life and the temporary curtailed expectation of life at age 55. All right, the complete one. The integral of Tpx dt, t from 0 to n, and then the curtailed, the summation of Kpx, where k from 1 to n. All right, no matter what, we need to get an expression for Tpx. Tpx is e to the power minus mu t, where mu here is 0.052. All right, we get the expression for TP55, and therefore we can simply substitute into the expression. And then we get the first quantity, 13.9898. This is the 25-year temporary expectation of life at age 55. And then for the 25 years temporary curtailed expectation, the summation of KP55 from K equals 1 to 25. And again, KP55 is simply e to the power minus 0.052K. And we get the curtailed expectation, which is 13.6292. All right, that's it for today's video. Thank you for watching and see you in the next video.